Hello, I'm Alexandra Moroianu and I'm the lead author of this new paper. To understand why the result is important, we're going to ask each other a few questions. Benito Marcote is a co-author on this paper and has had long experience working on fast radio bursts. Benito, for anyone who's not familiar with fast radio bursts, why are FRBs such fascinating sources?
FRBs are remarkable sources because they are extremely energetic flashes of light that come from very far away galaxies. However, they only last the blink of an eye. They are really brief. And that's why it's really hard to detect them. You really need to look at the sky at the right position and at the right time. And that's why it has been extremely difficult to understand what produces these FRBs and what objects actually create these bursts.
Thanks, Benito. Ziggy Pleunis is another co-author of this new study. Ziggy, why are repeating FRBs important?
So we know of at least two types of fast radio bursts. We know of the ones that we only see once, and we know of the sources that repeat. And when we know a source is repeating, we can take the biggest and most sensitive telescopes on Earth and point to those positions to further zoom in on the locations of these fast radio bursts, because now we know where to look. Could you tell us what's special about this source that you studied, the FRB 2019-0417A?
Of course. So FRB 2019-0417A is a particularly interesting source because it's highly dispersed. This means it had to travel from really far away or through a really dense environment to reach us here on Earth. Alongside its high dispersion, we also know from the burst properties that it had to travel through a really big magnetic field. And then combining these properties together, it tells us that this FRB 2019-0417A must originate from an extreme environment, reminiscent of that of a supernova remnant or the aftermath of a supernova. And this is where the European VLBI Network comes in, the EVN. Benito is a support scientist at JIVE, the correlation center for the EVN telescopes. Benito, what did the EVN allow us to do that couldn't be done before?
The EVN combines antennas that are spread over the Earth, mainly located in Europe, Asia and Africa, and that's why we can actually achieve images with a very high resolution. So we were pointing these telescopes to this FRB, and then we managed to image it when it was flashing. With this high resolution, we managed to pinpoint the FRB to a galaxy that is thousands of millions of light years away. And actually, we found that the FRB is at the same position where a compact object that emits persistently in time is located.
Very cool. Ziggy, what can we learn from this new study?
Yeah, so what we learn now is this is one fast radio burst that's part of a special subclass of repeating sources that are hyperactive and that are coming from special galaxies. They come from dwarf galaxies, which are special and unlike our own Milky Way. And we're looking here at the extreme endpoint of stellar evolution. So after a star goes supernova, it could produce these sources that produce a lot of energy and that produces then the properties that we see in this repeating fast radio burst source. This establishes this special class of repeating fast radio burst sources, and it gives us a glimpse into the extreme endpoints of stellar evolution.
Thanks, Ziggy. This result associates a repeating fast radio burst with a persistent radio source in a faraway galaxy. And results like this are helping us get closer to uncovering what is producing these mysterious fast radio bursts and where they might be coming from. This is part of a larger program where we combine telescopes from around Europe, Asia, and Africa, also known as the EVN, to look at repeating fast radio bursts and pinpoint exactly where they're coming from. We'll be back with more exciting results in the future. Thank you.